Greetings, Mathies. We're looking at 6-6 sketching quadratics. Now that you know intercepts, it's out of 21D, and let's just try one of these as a little warm up. Maybe you've already done a warm up today, but keep warming it up. Fraction work, simplify the fraction. Well, it's two fractions being divided. Maybe pause me until you got it. Try. Let's skip that one and just do these two, A and C. All right. If we're multiplying or if we're dividing fractions, you can invert and multiply, just trying to keep you current. So let's multiply by this thing flipped over. It's 3b squared. And then we can do some ninja canceling. Oh, we can't. There's nothing to cancel. Multiply everything on top. So 7a cubed. Multiply everything on bottom, 3b cubed. Neat. In C, we need fractions. We need more fractions. I need more fractions in my life. So I need a 4 as a denominator. So take that 2x and multiply top and bottom by 4. You get 8x, because 8x divided by 4 is 2x. And then you can just add the common denominators. So fourths and fourths, you don't get eighths, you still get fourths. You're talking about ducks. You have x ducks and 8 more ducks, I guess. So now you have 9 x's. Cool. Can't simplify. When you walk out of here, I want you to be able to sketch graphs using quadratic intercepts. And last time we saw that with this, you could find the x-intercepts from here by setting this equal to 0. We can multiply by -1. And so your x-intercepts should be -1 and 3. Right? Find the y-intercept. Okay, well, if we need to do that, we need to expand this. And so this would be, I'm going to ignore the negative for a second. It'll be x squared. Do it down here, I guess. Oh, it may be easier with the y-intercept. The x value is 0. So instead of expanding, let's just put in x equals 0 because that intercept is not over to the left or right. So let's make that 0, and that's 0. So this becomes negative. 0 plus 1 is 1, and 0 minus 3 is -3, so this should be -3. So the y-intercept should be at +3. Okie doke. And then sketch the function. This is what a sketch looks like. -1. 1, 2, 3. 1, 2, 3. Here's my point at -1, at 3, at -3, and then connect them with a beautiful curve. Where's the vertex, the top part? I don't really know yet. Right, so if we sketch the function, it looks like that. Let's see if we're kind of close. Ooh, not too bad. Right, 3, -1, 3. Great. If sometimes they have a uglier format, you can still do the same thing. The x-intercepts here are both at +2, because I'm setting, this is really like saying x minus 2 times itself. So both of those values are at 2. Find the y, so it's going to look something like this. 1, 2, it's going to do open up like that. Or, yeah, it's going to open up because it's positive. Find the y-intercept. The y-intercept occurs when the x value is 0, so put in a 0 for that. You get -2, so you get -2 squared, which is 4. So the y-intercept should be 4. So then this becomes 1, 2 over, and 1, 2, 3, 4 up, and plot your point, and then connect them with a beautiful smooth curve, like that. Voila. Last one, we try to find the x-intercepts. I'd probably do that by factoring and set this equal to 0. So I'd first divide everything by -1, 0 doesn't care, so you're left with x squared minus 2x minus 3. And then when we factor it, it becomes 1 this time. This time I got it. It's 1, I know. Yes, it is, and no, it is. And minus 3 and plus 1. So the intercepts are x is -1. And the x is positive 3. Y-intercepts occur when the x value is 0. It's not over left or right, so let's put in 0 for that, 0 for that. Those become zeros. The y-intercept is 3. And then when you sketch it, this is all I want from you, right? Just like -1, 1, 2, 3, 1, 2, 3. Plot your points. Here's the intercept, -1, positive 3, -3, little smooth curve. If you can find the vertex, that's great. So it should look something like, should look something like that. Cool. Jump into 21D and sketch with your intercepts. See you later.